So in this video we are going to discuss important questions in the subject power system analysis. So we are discussing this question based on the priority, unit wise, priority wise, the important questions in power system analysis. Unit 1, power system. Question number 1. The single line diagram of a power system is shown along with the components data. So determine the new per unit value. So and draw the reactance diagram. Assume 25 MVA and 20 kV as new base of generator G1. So this type of problem is very important. It comes under the priority 1. And one more thing here we need to note down, that is in transformer T2 3 into 10 MVA. That means this transformer T2 is of 3 single phase transformer comprised into a single 3 phase transformer, and the voltage value is 20 bar 127 kV. So in MVA they multiplied with 3, and in kV in the HT side we need to multiply it with root 3. So this type of problem already we solved, so I'll share the link in the description. Second priority, so draw the reactance diagram. So this is also a reactance diagram problem, or in other ways we say it is a per unit type problem. So here the base value of 100 MVA 220 kV in 50 ohm line. So in the transmission line the base value is given. The previous problem generator is taken as a base, but here the base value is given in the transmission line. So we need to start the problem from this section and proceed in left hand side first, then right hand side, and find out the reactance diagram. And third question, so in this question generator as a base, loads are given. So in this problem all different types of loads are considered: load A, load B, load C and load D. So the ratings here you can see: in load A 60 megawatt 0.9 power factor lagging, and in load B 15 MVAR 10 kV delta connected capacitor, load C 300 MVA 0.8 lagging power factor at 11 kV, load D 52 megawatt plus J 66 MVAR, 12 kV. So these are the different types of load specified in the problem. So if you study this question, you can able to solve any type of problem in which the load is specified. This is the third priority. So these three problems are very important in exam point of view. Next we are going to see the bus admittance matrix. So question number 4, the parameter of 4 bus system are given as follows: draw the network and find the bus admittance matrix. So this table is given, draw the network and find the bus admittance matrix. So in this problem line charging admittance is specified. Instead of this line charging admittance, in some case they will mention half line charging admittance. So that type of problem is very important. So I'll share the link in the description. Go through these problems. Fifth priority, Ybus using singular transformation method. So this is a very standard problem and it is a very important problem. Study this problem, and here the mutual impedance is also considered, and we need to calculate the bus incidence matrix, primitive network, and finally we are going to find the Ybus matrix. And next, the last question is question number 6, explain the current power scenario in India and what is the need for power system planning and operational studies. So I'll share the link for the power scenario in India and the need for power system planning and operational studies. You can go through that. It is a theory question. The total installed capacity in India, and central sector share and state sector share, and the regional load dispatch centers, national load dispatch centers and state load dispatch center, renewable energy generation, how many percentage of renewable energy in the overall installed capacity. So those things are comes under the power scenario in India. And why we need the power system planning and operational studies. So fault analysis, short circuit studies, power flow studies, stability analysis, those topics comes in this question. So these are the 6 important questions in unit 1, that is power system. So now unit 2, it is power flow analysis. The first priority question is Gauss Seidal load flow solution, flow chart and algorithm. So need flow chart. Explain the computational procedure for load flow solution using Gauss Seidal load flow solution. The second priority, flow chart and algorithm of Newton-Raphson iterative method. I'll share the link in the description. Kindly go through it. And third priority, problem based on Gauss Seidal method. So here all the 3 buses are given. So first bus is slack bus, and second bus is load bus. So here P and Q are specified, so it is PQ bus, that is load bus, and the third bus is PV bus. P and V are specified, so we call this as PV bus or a generator bus. So all the three buses are available in this problem. So this is a very important problem. In some cases, instead of this diagram, they will give a diagram like this also. Both diagrams are same, the shape of the diagram alone differs. So in this problem, finally they also asked to find the slack bus power. So this is a third priority. And fourth one, problem based on Newton-Raphson load flow method. So this is a very standard problem. So you can go through this problem also. I'll give the link in the description. And fifth one, very important theory questions. First one is compare Gauss-Seidal and Newton-Raphson method. So tabulate that Gauss-Seidal versus Newton-Raphson. And second one, give the classification of various types of buses in the power system for load flow studies. So there are three buses, as you know: slack bus, load bus, and generator bus. And what are the quantities specified and what are the quantities to be obtained, that we need to explain here. And third one, write the need for slack bus in the load flow analysis. So I'll share the link for this also. And unit 3, symmetrical fault analysis. First priority question. So symmetrical fault analysis using Thevenin's theorem. So this type of problem is very important. So here 11 kV bus, two generators are connected in parallel, then followed by a transformer 1, then overhead line, transformer 2, then underground cable. And at the end of this underground cable, a fault occurs. We need to analyze this fault and find out the fault current. Second priority, fault analysis using Thevenin's theorem. So two parallel generator transformer units supplied to a two parallel feeder line, and at the end fault occurs. So this is a second priority question. So I'll share the link for these problems. And question number 3, which is also a symmetrical fault analysis using Thevenin's theorem. Very important problem. So go through these problems. And fourth priority, this one. So determine the total fault current, fault level, fault current supplied by each alternator for a three-phase fault at the receiving end bus. It's a very important university question. Here also we are using Thevenin equivalent circuit. And fifth priority, flowchart and algorithm of a symmetrical fault analysis using Zbus. And question number 6, determine Zbus using bus building algorithm. Here three buses are present. So reference bus to new bus, and existing bus to new bus, existing bus to new bus, existing bus to reference bus, and finally 1 and 3 existing bus to existing bus. So this type of problem, if you are study, then you can able to solve any type of problem in bus building algorithm method. And seventh one, symmetrical fault analysis using Zbus building algorithm. So we are going to use the Zbus fault analysis technique for the symmetrical fault analysis. So these are the important questions in unit 3. Now unit 4, unsymmetrical fault analysis. The priority 1 question is, draw the sequence network for line to line fault at the terminals of an unloaded generator. Also we need to mention the assumptions to be made in short circuit studies. So line to line fault derivation, you need to derive the line to line fault derivation. Finally you need to draw the sequence network for that particular derivation. And second priority is double line to ground fault. So for that also finally you need to draw the sequence network. Then third priority is single line to ground fault. So these three derivations are very important. And fourth priority, the problem based on single line to ground fault. So this type of problem is very important. And the fifth priority, problem based on line to line fault. And finally, discuss in detail about the sequence impedance and the network of synchronous machine, transmission line, transformer and load. So these are the important questions in unit 4. And unit 5, stability analysis. So the first priority question is, derive the swing equation of a single machine connected to infinite bus system. The swing equation derivation is very important. Second one, state and explain the equal area criterion. You need to explain the equal area criterion. Third question, critical clearing angle and critical clearing time. The derivation part of this, it is a third priority question in unit 5. And fourth one, flowchart and algorithm of transient stability study using modified Euler's method. And fifth one, problem based on the stability studies, find the critical clearing angle. Sixth one, another type of problem. So here also we are going to find the maximum angle of a swing. So these type of problems are very important. So these are the important questions in power system analysis in the exam point of view. So you can study these questions in priority order. So I have given the question in priority order. Okay, I'll share the links in the description. You can go through the link and study well and do your exam well. All the very best.